Okay, welcome back. Lesson 21, Solving Equations Containing Fractions. I strongly encourage you to clear the fractions legally. So get rid of the fractions in a legal way. A lot of people tell me they wish they would have learned that a long time ago. It would have made their lives easier. But again, this is with equation. You're allowed to do this when you're solving an equation that has fractions in it. So if fractions are present, multiply both sides of your equation by the LCD of all the fractions in the problem. If parentheses are present, use the distributive property, combine any like terms on each side of your equation, and then proceed as usual from there. So I'm going to let you read through that recipe. Then basically after you get rid of the fractions, you solve it like you would solve any old equation, isolating the variable and and check your answer. Let's dive right into the practice. So here we have an equation with fractions. Okay, now remember 6 really means 6 over 1. So I'm going to draw giant brackets around the whole thing, pick the LCD. Let's follow the recipe which says to pick the LCD for all the fractions in the problem. So 3, 2, 4, 1, LCD is 12. So you have to get comfortable identifying a common denominator. So 3 goes into 12, 2 goes into 12, 4 goes into 12, all those numbers go into 12. Now the catch is multiply 12 through to the numerators only. Big note to self, numerators only. Multiply, because that's what goofs people up. They accidentally send it to the numerators and the denominators and they create a mess. So multiply to numerators only. And the fact that you're doing it to both sides of the equation is what keeps it fair and balanced. Okay, so let's do that. 12 times 6 is 72. 72 over 1, is just 72. But hold that thought. 12 times 1 is 12. But hey, 12 on top of 4, or 12 divided by 4, obviously that's going to clean up and the fractions are going to go away. But hold that thought and just record temporarily. 12 times 1 is 12. But 12 over 2, we know that'll clean to be 6. And 12 times 2 is 24, but 24 over 3, gee, that's going to clean up, right? So the whole thing is when you arrive here, that cleans up very nicely and the fractions go away. So let's scoot this on down. I'm going to scoot that other example on down. And let's keep cleaning. So clearly that cleans to be 8, so 8x minus, that cleans up to be 6. 12 over 4 is 3, and then 72 over 1 is just 72. When you arrive here, see you're right back to normal balancing an equation. Letters on the left, numbers on the right. So move 3x over. Poof, fractions are gone. Life is easy, right? 8 minus 3 is 5x. Move 6 to the other side via addition. And again, why am I adding 6? Because the opposite of subtraction is addition, right? So I'm negating it from one side and bringing it over to the other side of the balance. 72 plus 6 makes 78. Divide both sides by 5. And remember, we're not going to get pretty little whole number answers anymore. We get x equals 78 over 5, an improper fraction. You don't have to turn that into a mixed number or a decimal or anything like that. Now, it said to check your answer, and throwing 78 over 5 back into the original is a pain, I'll admit it. So let's use Wolfram Alpha to check. And voila! When it's midnight and you have no one to help you, it's okay to check it in Wolfram Alpha. Lots of people have this app on their phone or device. You see I just typed in solve 2/3 x minus a half equals a 4th x plus 6. It gave me, it said, gee, I love that it interprets your input, and it interpreted correctly, and it says the result is 78/5. And that is exactly what we got. All right, so we've confirmed our solution with Wolfram Alpha. That was sort of the lazy man's way out, but I want this podcast to not be too long. And now let's try this last example here. And clearly I have the answer to this one snipped in, but I want to see how to do it in real time. So again, recipe says to draw giant brackets around it. You can throw this over 1 for symmetry. Then you can spot the LCD as being 5, right? So you can send 5 through, but if you look back at the recipe, and let's look back at that. It said if parentheses are present, use the distributive property before you do anything too crazy, I would say. So let's actually, clean that up a little bit before we distribute this 5. So parentheses are present, use distributive property, so 3y plus 9 all over 5 equals 2y plus 6 all over 1, basically. We want to take that LCD of 5 and send it through. Remember, we said to numerators only. Okay? Well, you don't have to do mental math. You can write it out. And I wouldn't even actually distribute it. I would write it out. So 5 times 3y plus 9 over 5 equals 5 times 2y plus 6. And you can say over 1, but it doesn't really affect it. Now notice, though, the whole goal was to clear fractions. Well, boom, boom, 5 divided by 5 cancels out. So you're left with 3y plus 9 equals, boom, boom, send that through, 10y plus 30. And now you're right back to an equation that has no fractions. And voila, it's easy to solve from there, right? Move 10y to the other side. 3 minus 10 makes negative 7y, and I'm just going to keep recording. Plus 9 equals 30. Letters on the left, numbers on the right, so I want to bring 9 across the equal sign, so I have to negate it, subtract it. So I have negative 7y equals, well, hey, 30 minus 9 makes 21. Well, hey, 21 divided by in the end, you divide by negative 7, right? So you get y equals negative 3. Now there we ended up with an integer answer. And again, in a very similar fashion, I could check that answer on Wolfram Alpha, but that one I already have the answer snipped in for you. So, hope that helps. Feel free to pause and rewind and rinse and repeat as many times as you like. Good luck out there.